Hello, everyone. Welcome back to the AAS YouTube channel. And this is part of the awesome stuff. This is the Sky and Telescope series. And I am super happy to have my colleague and Sky and Telescope author, Jim Bell, with us today. Hey, Jim.
Hello, Professor Timmis, my ASU colleague who I hardly ever get to see anymore since the global pandemic. It's great to see you.
Well, I'm doing all of these videos for everyone. But yes, I haven't seen Jim in person. I haven't seen you in person in probably a couple of years. So I was just
been a while. Yeah.
That's right. So I don't have to ask you where you're at because I know you're probably in Phoenix here, unless you happen to be visiting past.
Yeah, I actually split my time these days, especially in summer, right? Get the heck out of Phoenix. I spend a lot of time at Jet Propulsion Lab in Pasadena.
Cool.
I happen to be in Pasadena today, but I've lots of back and forth. Yep.
Did you happen to go to the AAS 240?
I did not.
Oh, okay.
I did not. I'm just going to be making my plans for the DPS this fall, though, the AAS DPS meeting.
Very cool. I will be there. Come visit me on the floor sometime. You can see me on the floor.
All right.
Very cool. Jim, that's a pretty awesome bookshelf behind you. And I see there's some dinosaurs and some margarita glasses. It looks like.
You know, you got to have,
there.
In addition to the reading, you got to have a little bit of light time off.
There we go. There we go.
You know, I do a lot like you. I do online teaching. And so I like to have sort of a booky background, you know, oh, that guy must be a professor. He's got books in his background.
Gotta be.
But then lighten it up a little bit with the top shelf stuff.
Very good. Very cool. Very cool. So I'm always curious how people get into the field. So let me just ask, how did you get into, solar system astronomy, solar system research?
Yeah, that's a great question. You know,
there's so many things to do in the world, right?
Oh my gosh. And like I think a lot of us in professional astronomy and planetary science, it started when I was a kid. You know, I was lucky enough to live in a relatively rural place with dark skies.
Nice.
And got a telescope when I was young. My parents and grandparents chipped in for a really nice 8-inch Meade Newtonian, which is a big bulky thing, but boy, it was great resolution, right? For a teenager out in the yard, and started looking at the moon and planets and just, learned about the sky as a map and got turned on to all kinds of stuff, solar system as well as galactic and beyond. But what really kind of tuned me in, again, like many in our generation, to planetary in particular, was the 1980 TV show Cosmos, right? Yep. And Carl Sagan. There wasn't much science on television back then. There was Nova, the PBS series Nova was on, and every once in a while they would do astronomy, but not all the time. But here's like this 13 episodes or whatever it was, an hour at a time of just like, here's the solar system, here's Voyager and Viking, and here's what astrobiology is, even though you've never heard of that, and taught by this guy who with this distinctive Brooklyn accent, right? Who could not speak the jargon that we can lapse into, but who could actually speak in English to normal people, right? And so really just like so many in my generation, a beneficiary of that, one of the earliest television science communicators, popularizers of science out there, just got me super excited about it.
Cool. Very nice. Very nice. Very nice. And I think mine was, a lot of mine was from the Apollo mission. I think I was around 10 years old when I was man on the moon, and that was very, very inspirational.
Yeah, I've got that going on too, because of course they were driving cars on the moon when we were kids, right? On TV. It's like, what? That's amazing. And then, like, I think like all of us, we've had teachers, mentors, supportive family that have we're just blessed to be able to be in this for a living. Yeah. Indeed.
Very cool. And that, I think, is going to take us to this very lovely Sky and Telescope article, which we will bring up. And flying with Ingenuity on Mars. And Jim, take us away.
Yeah, right. So what's up? We've got a helicopter flying around on Mars. Whoa, right?
Cool.
I mean, is that cool or what? So I'm not, just full disclosure, I'm not a member of the helicopter team, but I'm a member of the science team of the overall Mars 2020 mission, the Perseverance rover. Ingenuity, the helicopter that was carried underneath the belly of the rover to Mars, launched in the summer of 2020 during the global pandemic, the height of it, and then landed in February 2021. so a little over a year and a half ago or so, and carrying that helicopter, a completely independent spacecraft, a separate spacecraft. We call it a spacecraft, right? It's a helicopter, but it's got power systems, computer systems, telecom systems, thermal systems, propulsion system. It's a spacecraft that happens to be relatively small and sitting on the surface of another planet.
Let me just ask a question here. Don't helicopters need some sort of an atmosphere to get the lift going?
They do, and there is some sort of an atmosphere on Mars. It's very, very, very thin, right? It's 1% of the thickness, the particle density of Earth's atmosphere. So, in order to fly in that very thin atmosphere, that's like being up at 85,000 feet.
Yeah,
Earth's atmosphere, right? You can't fly a helicopter up there in the Earth's atmosphere because there's not enough lift, not enough thrust, right? But you can create more lift and more thrust by doing two things. Really big blades.
Okay.
Right? These blades are 1.4, almost 1.5 meters across.
Ooh, wow.
And there's two of them, and there's spinning, and you spin them super fast, 2,900 RPM. Right? You just crank them as fast as you can make that. Those little motors go. And so super fast spin, bigger prop area, and actually a third thing, very lightweight payload, very lightweight fuselage, right? The fuselage is not much bigger than one of those boxy tissue paper boxes, right?
Oh, wow. That is small.
And it's composite materials, all lightweighted, and those blades in that environment will lift it up. And we knew it would work because we recreated that environment, that the team recreated that environment at JPL in a vacuum chamber. They added a little bit of Mars CO2, got the pressure and temperature right, and took off.
Up it went. That is all very cool.
Yeah. So again, I'm not part of the team, but the team has a spectacular story. And as part of the rover team, our job and the team that I run, the imaging team, the camera team, Mastcam-Z camera team, which is based at ASU. Our job was to document all this, to photograph and video document the first flights of the Ingenuity helicopter. So we had to work really closely with the team, and I got to know a lot of those people and their stories, which is described in the article, the genesis of Ingenuity, where the helicopter came from, the people involved. It's a fascinating story. And so I did a little research in it. And I asked, hey, have you guys written this up? Has it shown up anywhere? Does the public know about this? And there's, some blog sites and all that. But of course, the Sky and Tel audience is a very different audience. And, lots of excited and excitable amateur and professional astronomers. And of course, the visuals are beautiful. So I pitched it to the editors there. I'm a consulting editor of the magazine. So I have some relationship with the other editors, pitched it. They said, yeah, it'd be a great story. So that was the genesis of the story and my connection with the helicopter. So the article, you can scroll down if you want a little bit. The article talks a little bit about some of the technical details.
Here's our big
right? So there's a picture of it. It's got that solar panel on the top, like a hat. There's a battery inside the body, that fuselage. Again, all very lightweighted. The solar panel recharges the battery, and the battery runs the motor for the rotors. It runs the comm system. It runs the computer. There's cameras. There's a little tiny IMU, inertial measurement unit that's like gyroscope inside that allows it to do a whole bunch of its own sort of self-navigation. So it's very, very autonomous little vehicle. We tell its computer sort of where you are. We make like an XYZ map of the landing site. Hey, here's where you are. Here's where we want you to go.
Cool.
Fly over here, fly back, take this route, go to this height, take these pictures, et cetera, and go do those things in an automated way. It's not joystick.
It's not a joystick. Nobody's joystick going like this.
Nope. Even just like the rover isn't joysticked either, right? It's the same thing. We communicate basically once a day with all these rovers on Mars. So very, very autonomous, and having to make a lot of its own autonomous decisions about, wind gusts, temperature variations, the details of how it gets from point A to point B. a lot of that sort of built-in smarts on the vehicle. So that really came from a lot of collaboration between the helicopter engineers and the terrestrial drone community. We've got colleagues in our department who work with drones, and they're around the world. Drones are becoming much more part of science and field work, right? And that community is getting, super smart about building in a lot of autonomy into these vehicles. And so some of that comes from NASA, some of it was from that community to NASA. So lots of great back and forth there in terms of
interdisciplinary. Nice.
Yeah. So you keep scrolling down. I'm just reminding myself of the things that I covered here. Oh yeah. So here, I like this picture in the upper right because you get a sense of the scale, right? You can see the size of that thing. Here's some technicians working on the actual flight helicopter, and you see those two blades about 1.5 meters across. They spin opposite to each other at that super high speed. It's got that kind of foil on the outside for thermal control, heaters on the inside, the battery, the cameras, the computer, the communication system. It basically set up on its own a little Wi-Fi network between the helicopter and the rover. Probably like the first Wi-Fi network on Mars. And they talk to each other that way. There's not enough power in this transmitter to go back to the Earth, to send signals back to the Earth, or even to get up into Mars orbit with all those orbiters, which is what the rover does. The rover relays its signals into Mars orbit. Where the NASA or ESA orbiters then relays it back to the Earth. So the helicopter always has to be in line of sight of the rover for that Wi-Fi network to work.
That's so cool.
Yeah.
So cool.
Yeah. And then there's some of the engineers. Mimi Ong was the project manager for a while, an expert in networked communication systems at JPL. She, obviously that's a pretty thorny network communication problem to solve. You're hundreds of millions of miles away, and you got these two, the base station and the Wi-Fi network have to link and shake hands and all that kind of stuff. But more importantly, she was just so enthusiastic about this project. I don't know if you've seen her give interviews or when the helicopter was doing its first flight. She's like just supercharged with excitement about this project and about the potential for these kinds of drones in planetary exploration, which is super exciting stuff. Yeah. So it was great I got to interview these folks and Mimi and others, and they get, some stories and some quotes in there. And it got I describe in the article how it got connected to Perseverance. Ingenuity got connected to Perseverance through science, through the idea that, a bunch of engineers working on robotics, working on drone kind of robotic systems at NASA and elsewhere, like, hey, what could this system do to enhance our science in a place like Mars, or a place like Titan, where drones are going in the future, or a place like Venus, which has a thick atmosphere and you can fly drones around, right? Easy. What could we do to augment the science that we're doing in these places? And really, the answer is you use it as a scout, right? The same way that explorers would use scouts in the early days of exploring our own planet. You send someone or something out there ahead of you, especially to places that you can't go. Like there's many places we can't send the rover: giant sand dunes, big boulder fields, deep cliffs, whatever. But you can send a drone there, and you arm it with some cameras and maybe in the future other instruments, and get more information that can help with the traverse path, help decide where to take our samples that we're collecting with the rover, all that kind of stuff. Cool. So it was great that the initial connection was with the science, these engineers, these technologists trying to find how can we increase the science. Of course, as scientists, we're like, yes, that's the right approach.
That's right. Way to go.
But there's a whole other part of this, right? That's tech demo. The whole thing was a tech demo and just showing the capability, demonstrating the capability for future missions of this kind of drone technology.
And here is a live field test, which
so this was in April of last year. We did a bunch of practice sessions where they were practicing spinning up the blades without taking off. We were practicing pointing at the helicopter, trying different modes and video streaming and all that. We haven't done a lot of video on Mars, right? And then so these are frames from a video
Cool.
that there's a link at the end of the article that describes where you can go and see our videos. We put them all on our Mastcam-Z public website.
Nice.
And then lo and behold, it was a very simple, Wright brothers kind of moment, right? Just spin, go
Come
up,
on.
about 3 meters, stop,
Very cool.
turn the body 90 degrees, and then come back down again. But when you watch the video, you can see it. You can see it actually fighting the wind. You can see that there's wind gusts, and it's kind of like pushing back against the wind, but it kept stable, right? It's, using its IMU to keep track of where it is, and it kept stable and came back and did a nice soft landing. So
very nice,
very simple, right? In the annals of aviation, it's not like the most spectacular flight ever, but
hey,
it's the first flight on another planet.
First
Flight on another planet of a powered flight vehicle. So it was just really exciting for those of us at ASU who are working on the project to participate in that kind of aviation history, documenting this spectacular achievement.
And even those of us who don't work on it find it exciting. So it's all good.
Absolutely. Yeah. So that was pretty cool. And then that was the first of 5 initial flights that were the so-called tech demo phase, and each flight got a little more complex than the previous one, a little higher up, and then out of this, side to side, and then a little more complicated paths, taking better pictures and sort of time-lapse animations from its own cameras along the way. And we recorded all of those both at wide angle and high resolution, both just for the historical aspect of it, but also the engineers are interested in how did this thing actually fly. One bummer of a regret, we couldn't follow the helicopter with the cameras.
Oh, it doesn't pan.
We couldn't. It does pan and tilt, but the problem is the pan and tilt motors interfere with the Wi-Fi signal. The noise from the pan and tilt motors interferes with the Wi-Fi signal. So we had to stay fixed. So in the later flights, helicopter takes off and it goes out of the field of view, and you're like, wait, why don't you just follow it, man? Just go. And it's like, oh, we wanted to, we could have, but we couldn't do it. So next lesson learned. Next time we won't do that. We'll be able to pan and zoom. But we could zoom, and we did zoom. We have zoom cameras there on Mars with the Mastcam-Z system. And so, and one of the other cool things that happened, we saw on multiple flights, totally unexpected, would take off, leave the field view, and come back with this big dust cloud.
Yeah, I was gonna
kind of like, remember that character Pigpen from Charlie Brown?
And he was
had all that dust around him. It was
him.
like that, it was like this, the helicopter would bring the dust back. And this got our atmospheric science colleagues on the team and in the community very excited, because it's basically the helicopter is acting as a known vortex source to basically excite the boundary layer between the atmosphere and the surface,
the ground,
and lift up that dust and move it. And so because the force and the nature of that force is so well known for the helicopter, you have a great sort of control experiment. Nice. And in the background of some of these scenes, some natural dust devils are off kind of growing across, doing exactly the same thing all naturally, because Mars is a dusty, windy place. And so kind of a cool extra bonus atmospheric science investigation has come out of the helicopter flights.
Particulate fluid dynamics on the surface of Mars. Very cool.
Yeah. So a lot of this text is the backstory from Mimi, from the project scientist Matt Gollenbeck, from my colleague Justin Mackey, who works on Mastcam-Z, who is also one of the imaging leads for the helicopter. A guy named Hovard Grip, who is the pilot, the chief pilot, right? Even though it's a drone, you have a pilot.
You got a pilot.
Yep. So a lot of the stories that they had to contribute are in there as well. So that's all kind of cool. And then some of the details in that table down below. If you scroll down a little bit, the sort of comparison with the Wright brothers, right?
I'm not familiar with the bat. What is the bat?
Yeah, that was this fellow who tried to built a steam powered sort of flapping wing machine, and didn't, quite, I guess, sort of got off the ground, and it's arguable and debatable if that the first
But he tried.
powered flight. It's it was a flight, a short,
Sure.
unknown because it wasn't well documented, but it was one of these, the steam engines turning a crank, which is flapping these wings, which look like the wings of a bat, right?
Steampunk.
Yeah. Now, the one that we all really are most familiar with is the Wright brothers, of course, which was human powered,
Right.
to get it going, and then a little bit of engine to power the flight, and that was very, very short first flight. Right, very, very short, and in fact, Ingenuity's first flight was almost three times longer, going up and down. And of course, Ingenuity, totally automated, built by people, commanded and programmed by people, but on its own devices to do that automated first flight.
That seems like a pretty good step over 118 years or so.
Yeah, it's pretty cool.
That's a pretty
very, very
pretty
cool
step there.
Yeah. So after getting those 5 flights in the bag, which was after near the end of May of last year, helicopter's still in great shape. Still lots of power, no systems problems, no flight problems. And so the team went to NASA headquarters and said, hey, you know what? We've got a perfectly working drone here. How about let's do some kind of an extended mission and see if we can really test this thing out in a different way. And instead of just a tech demo, does it fly? Can it control itself? Can it get from point A to point B? Now, the pitch to headquarters was, hey, let's do an operational test mode. Let's see if we can get it to go places that the rover can't go. Let's see if we can get it to document some of the geology and landforms that the rover can't see from our current location, and that we can't see as well from orbit because we can get higher resolution from a low elevation platform, right? And so that was approved by headquarters. And so the helicopter has been sort of hopping along with the rover as we've been driving around Jezero Crater, now exploring this ancient delta in what was an ancient riverbed and lake environment. Pretty spectacular. And the helicopter's been ahead of us or behind us, but nearby the whole time, and scouting out places that we couldn't go, including the front the cliff of that delta well before we got there. So super helpful, not a critical required part of the science, but hey, here's a bonus. You guys need to start planning, the engineers need to start planning how the rover is going to drive through this terrain. Here's some advanced scout pictures at a scale much better than we could get from orbit, and better than we can see from the ground because we're hundreds and hundreds of meters away. So now going on, hundreds of meters flights across this dangerous terrain that we couldn't drive through, to places that we were going to see in the future. And that has been a super cool demonstration of the potential for vehicles like this to augment science on rovers or landers or other missions. And again, not just on Mars, other places with atmospheres as well.
So let me ask one question on the helicopter. So those rotors are turned by battery. And so what's the longest flight time you can do, or how, out of the batteries that you got? Does it fly for 1 minute, 1 hour, 1 day?
Not an hour, but I'm trying to remember now what the longest flight that we've done now. Minutes. It's minutes to tens of minutes. Yeah.
Recharge time.
Yeah, and that's actually become an issue now that we're a year and a half, 500 sols, 500 Mars days in. That solar panel on the top of the helicopter doesn't spin; it's fixed.
Yes,
but it's getting dusty. And all this famous Mars dust, right? Settles on.
There's no washer cleaners out there.
No washer cleaners, and no rain, right? Yeah. And that's slowly choking off the amount of solar power. So the battery ability to charge the batteries is slowly weakening with time. But
sure,
it was supposed to survive for 5 flights, and I think it's close to 30 now. Helicopter's taking close to 30 flights now.
Oh, this is hilarious. You got a Wright brothers field in this
yes.
in this map. Very cool.
Yep. So we
I love it.
picked an area where there were very few obstacles, where we knew things would be nice and
Mhm.
easy for
Mhm.
takeoff and landing. It's not going to land on a rock and tip over, because that would be kind of the end of the mission.
Disaster.
Yeah. But that whole area to the left, where you see that jagged yellow line going through the
Uh-huh.
left,
Uh-huh.
that's pretty big sand dunes, and we
Yeah.
cannot drive the rover in there. And it's different stuff. It has a different chemistry, different mineralogy than the other
Oh,
places we landed on. So we can't,
okay.
it was very difficult to figure out. We ultimately did get into a little piece of it where we could get in before hitting the sand, but we couldn't characterize the whole area very well. So that's partly why the helicopter was sent over there, to do that kind of scouting and high resolution imaging, to give that information to the geologists.
Yeah, now I could see why if you had other kinds of instruments on a suitable helicopter, you could do a lot more on that
Yes.
geochemistry. Uh-huh.
Yes. And that's of course the plan for the
Boom.
the helicopter that's going to
Uh-huh.
go to Titan,
Nice.
right? And that's going to have not just cameras, but spectrometers, thermal sensors, and other kinds of.
Is that a bigger helicopter?
That's actually a quadcopter
Quadcopter, very nice.
design. Yeah,
Which
but
people
they
can
will,
get
that, like I said earlier, it's a small community. That one's called Dragonfly, that mission.
Mhm.
And it's a small community, and they're all talking to and learning from each other. That mission will be run out of Johns Hopkins Applied Physics Lab on the East Coast, but they and JPL talk a lot about these things. And so
Uh-huh.
whatever lessons learned, Ingenuity can pass forward to to Dragonfly or other drones, if that's going to happen.
Yeah, and we actually did we did a video on the Planetary Science Journal on Dragonfly, and so we'll put a link to that in the video in the description below this video.
Great.
All right. Memento.
Yeah, so lots of happiness, lots of celebration. People on that team worked really hard. They were a little
I love this.
yeah, there's Mimi there. They were a little it's been described as what Skunk Works was, a team within a big aerospace company, a small nimble team trying to push the edge. Kind of a little Skunk Works team within JPL, very similar to you remember the Mars Pathfinder Sojourner rover back in the mid 90s, right? That was a little team embedded within the large structure that was given a difficult problem and flexibility and some resources, not a lot, but some, to go solve that. Hey, let's get a rover working on Mars. These folks were given a similar kind of, hey, let's demonstrate powered flight on Mars, and I think a lot of folks within the more bigger conservative institution and NASA in general thought there's no way this is going to work, right? It's a super hard thing to do. And yet, hey, they got to celebrate, right? Really
They are mighty things. I love that.
Yes, indeed.
They are mighty things, right?
Indeed. Yep.
Awesome.
Yeah.
So nice. Very cool. And then we have a selfie.
Yeah. Yeah. So generally, helicopter flies in midday when it's nice and warm, and when a lot of the thermal gradients in the day have settled down. So not a lot of atmospheric turbulence, although some.
Yep.
And so middle of the day at this latitude, at this
Take a
season,
ripple.
the sun's right overhead, right? And so the casting this nice shadow, looking back down.
Looks like a dragonfly.
Yes, it does. Yes.
And Jim had mentioned the all of those videos are on the Mastcam-Z website, and so here we go.
Yep.
Copter videos.
Yep.
And we got down here illustrated mosaic. Oh, okay. A put together of the shots.
Yeah. So right now the rover is actually right about on the tip of the delta above the word reconnaissance in the caption. Yeah. So
right here.
rover's over the, let's say, oh no, sorry, we're to the right. We're above the word view on that same sentence.
Oh, you're way over here.
Yeah, up there, right. We'll be making our way around to the delta. We just took our first 2 samples of the sedimentary rocks of the delta. We get to photograph those samples with Mastcam-Z as part of the confirmation process. So you can see the little core sitting at the end of the drill bit. And those have now been put inside the rover, and we have 10 rock samples inside the rover now. And so the fun part is, collecting more as we drive around on the delta, filling up the tray inside the rover, and then at some point transferring them to another vehicle, a lander with a rocket on it that's going to launch them into Mars orbit, and meet with an orbiter that will bring them back to the Earth. This is
Very nice.
our sample return.
Very nice.
The highest priority planetary mission in the recent planetary decadal survey. And the Perseverance rover and Ingenuity and Mastcam-Z and all that, we're the first part of it. Collect those samples. So these won't just be random samples, right? They're very carefully selected to tell us something about ancient Mars and watery environment and the lavas and the chemistry of the planet and the minerals, and maybe learn more about, was it an inhabitable environment? Was it an inhabited?
What is it environment?
Yes. Right? And those are big questions to go after. And Ingenuity's been playing a role in that.
Those are big questions. Those are big questions. One of the things we probably got inspired by, from looping back to the beginning, from some of Carl's opening material on life. It's a big question.
Indeed.
Very, very cool.
Indeed, you're right, Frank. Absolutely.
You did that well. You did that very well. Indeed. Very nice. Jim, thank you so much for walking us through this very lovely Sky and Telescope article on flying with Ingenuity.
Well, it was a fun story to tell, and hope people enjoy getting into the details. And still going. You can follow along online on NASA or JPL's websites with the Mars 2020 mission and Ingenuity helicopter.
And you mentioned it a little bit that automated drone type vehicles would be used on some of the upcoming space missions. And I'll just ask, where do we go with this? Let's say over the next 5 years, or the next decade for the next mission. Do you see helicopter drones becoming part of a regular thing that you will send up if you go to Enceladus, or you go to Titan, or you go anywhere? So just where do you think this is going over, let's say, the next decade or so of the next missions to?
Yeah, totally see that potential. And not, we could extend that conversation, not just drones, because there's a lot of places in the solar system without atmospheres, right? And a drone won't fly. Yeah, but robotic companions that can go along with bigger missions or human missions to the moon and Mars in the future, right? And you could have working as scouts. There's some people talking about potentially sending some additional helicopters on the next Mars sample return opportunity to go fetch those little sample containers from the Perseverance rover. So, kind of those kinds of mechanical tasks, right? So I'm just super bullish, Frank, on robotics and robotic vehicles supporting each other and supporting human exploration in general as part of the future of solar system exploration. You can also talk about submersibles if you like, if you wanted to, drill down through some ice and poke around down there. You said next 5 to 10 years. So. My time. Yes, eventually, yes. Yes. Very cool. Very cool. Jim, thank you so much for walking us through your very lovely article. And that will do, everyone. And I hope this made your astronomy day and planetary science day just a little bit better. And we will see you on the next one. Bye-bye.